Here's a simple explanation of how areas of high pressure and low pressure form at the surface. The left-hand map shows upper-level waves by the warm colors. The right-hand map shows surface temperatures with the color fill, and surface pressure with the white contours. Notice how the cold air is over Lake Superior. On the left is an upper-level wave. It is generally located around 15,000 feet or 3 miles above the ground. Rising air is located ahead of these waves. As a result, an area of low pressure forms at the surface ahead of these upper-level waves. This map shows all the features together. Notice how the surface low is positioned below the rising air aloft ahead of the upper-level wave. As we go forward in time, the surface low hangs on across the arrowhead of Minnesota, while the upper-level wave continues toward Lake Superior. The faded text shows where the surface low should be located, but isn't. Moving ahead a little further in time, the actual surface low lingers over the arrowhead, while the upper-level wave continues east-northeast. Rising air is now located over Lake Superior. Continuing forward in time, the actual surface low remains across the arrowhead of Minnesota, while the rising air is located along the northern shore. The faded text on the upper right shows where the surface low should be located, but for some reason is not. This last image shows the weakening surface low near Thunder Bay, Canada, with the rising air to the northeast in south-central Ontario. So why is that? If there is rising air aloft with warm air at the surface, it will be much easier for the warm air to rise and for the surface low to deepen. As a result, you will get a strong area of low pressure at the surface. However, if there is rising air aloft with cool air at the surface, which happens to be the case over Lake Superior, then the air at the surface is stable and it won't want to rise, and you will only get a weak area of low pressure. If we compare the two cases and assume that the rising air aloft is equal in both, you can see how the response is better over the warm air than over the cold air. In the early summer, the land is much warmer than the cool lake waters, so storms tend to develop over land more easily than over water. However, in the late fall, the exact opposite is true, and storm systems can intensify quickly over the warm lake waters.